So hello, a very good evening to all. I am Vivek, and in this video, I am going to provide you a detailed solution of your AIT 2 exam, right? So I hope सबने पेपर अच्छा किया होगा, सबका पेपर बहुत अच्छा गया होगा. So in this particular video, we are going to discuss some questions in which you are maybe facing some problem, right? So let's start with the today class. Ah, Before starting the class, I tell you one thing. In this class, we are going to solve those questions which are some, no, which are in which questions students facing some problem, right? So basically, try to solve some hard questions or some medium level of questions, and the easy questions we are going to solve in the last, right? So we're starting with the some questions जो थोड़े से मुश्किल थे, थोड़े से हार्ड थे, उन क्वेश्चन से हम लोग स्टार्ट करेंगे. And in the last we are going to discuss some easy question as well. ठीक है, तो चलो स्टार्ट करते हैं आज की क्लास को फटाफट. So the first question is that is question number 75, right? So this question is a totally numerical based question, right? So this question is from the solid state, right? So in this given question, a metal has an FCC lattice. So what is given in this question? Let me write first. So FCC means what? FCC means Z is equal to, that is number of atom, that is equal to 4, right? Because FCC is given, so you all know that Z is equal to 4 in case of FCC. Now the age length is also given, so age length is equal to 404 picometer. For picometer, we can write as 10 raised to the power minus 12 meter, right? Now the density of the metal is also given, so density is also given, which is equal to 2.72 gram centimeter cube. So we can convert this meter into centimeter as well, right? Now you have to calculate the molar mass. So this is a very, very simple question and totally formula based question, totally, right? So we know that what formula we know beta? We all know that the formula for calculating density is nothing but that is equal to molecular mass into Z, that is the number of atom, right? And divided by any Avogadro number multiplied by AQ. So this is the formula for calculating the density, right? Now, all values are given. We just need to calculate this value, that is M. So let's calculate the value. So again, density, we can calculate molecular mass by using the formula E into Na into AQ, and this is divided by Z. So just put the value, nothing else. So we know the density is given, that is 2.72. Na is given, that is 6.023 into 10 raised to the power 20. They have a Avogadro number. Now age length is also given, that is 404. And convert this into centimeter because density is in centimeter. So we can convert this 10 raised to the power minus 10 and whole cube, right? And their whole cube and divided by what beta? Z. What is Z here? That is 4. So this is a very simple calculation. So on solving, you will get this 27 gram per mole. So this is the molecular mass. So which option is correct? That is option number A. So option number A is absolutely correct for this question, right? So I hope this is clear to you. Chalo. Now, the next question is, in a face center cubic lattice, a unit cell is shared equally by how many unit cells? So they are asking in the face center. So basically, in case of face center unit cell, we know that the contribution for the face center is nothing but 6 into 1 by 2, right? That's is equal to 3. And one atom are present at the corner as well. So it comes out to be 4. So, but in this question, they're not asking total number of atoms. They're asking in face center cubic lattice, a unit cell is shared equally in how many unit cells? So they are shared it because if you taking the consider the example of your room as well. So if your room has the 6 spaces, right? उसके भी 6 space होंगे. That is the bottom one, front one, sideways, है ना? So total we have a 6 spaces. So how many faces that are shared with the unit cell? That is 6. So the correct answer for this question number 76 is 6. This question is also from the solid state chapter. Now move to the question number 77. So basically in this question, a crystalline solid XY has a CCP arrangement for its element Y. So X occupies. So this is a very simple question. We all know that in case of the CCP, right? So in case of the CCP, right? So basically if you consider in CCP arrangement, right? So in CCP arrangement. So in CCP arrangement, right? A unit cell has total how many particles? Four particles. So unit cell having four particle, right? That is four particle, right? Always remember that is four particle. So in CCP arrangement, unit cell having four particles. And now in the given question, the formula is given x, y, q. So to keep this formula x, y, q, number of x particle. So what is the number of x particle to keep this formula x, y, q beta? Because in the CCF arrangement, unit cell having the four particle and it is already given the formula is x, y, q. To keep the formula x, y, q, the number of x particle is nothing but is equal to 4 upon 30 or which on solving you'll get 1 point, sorry, 4 upon 3. So 4 upon 3, so on solving you'll get 1.33, right? So on solving you'll get 1.33 because the formula is given x y cube. So it's equal to 1.33. Now in the CCP arrangement, octahedral sides, how many octahedral sides are equal? 4. So therefore the percentage of x particle, right? The percentage of x particle occupying the octahedral side, percentage of x particle, which occupy, right? Occupy, just wait. Yeah, right? Which occupy octahedral site. Octahedral sites, right? So the percentage of X particle occupying the octahedral site is nothing but 1.33 divided by 4 into 100. So on solving, you'll get around 33%. So which option is correct, beta? So which option is correct? That is 33% of the octahedral word. So this is the correct one. So this is for question number 77. Now, question number 70 is this is also from the solid state chapter. That is which of the following exists as a covalent crystal in the solid state. So this question is from the classification of the solid, and it's a very simple question because we know that all that a covalent crystal. So silicon, that is group 14 family. So silicon belongs to the covalent crystal in the solid state, right? So this is a very simple question. Now, question number 79. According to this question, perovskite, a mineral of titanium, is found to contain a calcium atom at the corner. So calcium atom at the corner, oxygen atom at the face center, and the titanium atom at the center of the cube. So the oxidation number of titanium in the mineral is. So you have to calculate the oxidation number. Now we know that the calcium atom are present at the corner. So the calcium atom per unit cell, per unit cell. We know the contribution at the corner is 1 by 8. So this is equal to 1. Similarly, O atom, oxygen atom at the face center. So O atom at face center, right? So O atom present at the face center. So the contribution at the face, we all know 6 into 1 by 2. Abhi we discussed kiya tha. That is 3, right? And the titanium atom is present at the center of the cube. So the titanium atom present at the center. So this is equal to 1. So total number of atom is how much? That is, this is equal to how much, beta? Tell me fast. That is, this having 1 and this having 1, this having 3, right? So the formula become calcium 1, titanium and oxygen having 3. So CaTiO3. Now, you have to calculate the oxidation number of titanium. So we know that the oxidation number of calcium is 2, titanium is X, and this is 6. So this is equal to 0. So X comes out to be 4, right? So the value of X is 4. So which option is correct, beta? This one. The value of X is 4. So calcium atom present at the this and titanium is present at the center of the cube. So we can calculate the oxidation number of titanium and this comes out to be 1. So this is how we actually calculate this value. So I hope this is clear to you. Hmm? Chalo. Now, let's move to the next question. So this question is also from the solid state. So basically, this chapter contains a lot of numerical question in this paper. So according to the question number 80, the packing efficiency of the two-dimensional squared cell. So you have to calculate the packing efficiency of the two-dimensional square unit cell. Not asking three-dimensional, they're asking two-dimensional square unit cell. So we know that how will you calculate the packing efficiency, right? So basically, we can calculate the packing efficiency by using the formula that is area covered, right? By using the formula like area covered, right? So packing efficiency. So we know the formula of the packing efficiency. That is packing efficiency is equal to area covered by particle, area covered by particles, hmm, and divided by the total area. Divided by the total area. So we know the formula. Now, in case of this, you can calculate this diagonal, right? So how will you calculate this diagonal? You know this length, you know this thing, right? So this is R, right? This is also R, and this is R plus R, and this is 2R. So we know this thing, this is equal to 4R, and this is equal to A, right? So this is the A, this is also A. So you can easily calculate the diagonal, right? So if A is the length of the unit cell, so what is the diagonal AC? So you can calculate diagonal AC. So diagonal AC is equal to how much? Yes, it comes out to be under root 2A. It comes out to be under root 2 into A. Because we know this is A and A. So by using the Pythagoras, right? So we can calculate say that AC square, that is A B and C. So AC square is equal to AB square plus BC square. We know this A square plus A square. This is equal to 2A square. So this comes out to be under root 2A, right? AC. Now, we also know that this AC also equal to what? That is 4R. As we can see that this is R, this is 2R, and this is again R. So this is also equal to 4R. So this 4R is equal to under root 2 into A. Right. So from here you can easily calculate the value of A. So A comes out to be 4R under root 2, or we can also write as 2 under root 2R, right? So this is how we can write the A. Now you have to calculate the effective number of particle. So what is the effective number of particle here, beta? So basically the effective number of particle, because number of particle you must know. So here the effective number of particle, effective, yeah. So the effective number of particle. So the effective number of particle is here is that is 4, right? And their contribution is 1 by 4 plus 1. So this is equal to 2. So the effective number of particle here is nothing but 2. So what is the area occupied? So area occupied by the particle is 2 into pi r square. So this is the area occupied. Now you can easily calculate the packing efficiency. So we know the formula of packing efficiency, that is area covered by the particle, which is equal to 2 into pi r square into the total area. The total area, that is the 2 into under root 2r and cube. So on solving, you'll get the value that is equal to pi by 4. So which option is correct, beta? Pi by 4. Pi by 4 means 78.54%. Yeah, that is option number D. So option B is absolutely correct for this question, right? So I hope so I hope this is clear to you, right? How will you find the packing efficiency of the two-dimensional square cell? Okay. Let's move to the next question. That is question number 81. So this question is also theoretical question from the solid state. That is, a particle solid is very hard and has a very high melting point. In solid state, it's a non-conductor. While in the molten state, it conducts electricity. So this type of solid is. So किस type का solid होगा? ये obviously NaCl की बात कर रहा है. So it is a ionic solid. Now move to the next question. That is question number 82. So what the question number 82 asks better generally? So according to this question, a compound formed from the element A and B has a cubic structure in which atom A are present at the corner as well as the face center, and the atom B are present on the edge center as well as the body center. Now you have to calculate the formula of the compound, right? So you have to calculate the formula of the compound. Now you can see that atom A, that is atom A, present at the corner, right? So atom A per unit cell. So contribution at the corner is 8 into 1 by 8. So this comes out to be 1, right? So this comes out to be 1. Plus, as well as this atom are also present at the face. So contribution at the face is 6 into 1 by 2. That is 3, right? So this total number of atom is equal to 4. So A कितना आ गया यहाँ पे? 4 आ गया बेटा, ठीक है? Now atom B. So atom B के बारे में पता करो. So atom B are present on the edge center as well as the body center. So B are present at the edge center. तो edge पे contribution कितना होता है? 12 into 1 by 4 plus में body center, that is 1. So this comes out to be 4. So what is the formula? So this comes out to be A ratio B, which is equal to 4 ratio 4. So the formula become AP. Right. So this is also a very simple question. So option C is absolutely correct for this question. Right. Now, move to the next question, that is question number 83. So what the question asks basically, a binary solid A plus B negative has a zinc blended structure with the B negative ion constituting the lattice and A plus ion occupying 25% of octahedral voids. What is the formula of the solid, right? So you have to calculate the formula of the solid, right? So चलो देखते हैं फटाफट क्या होगा formula. So let us assume, ठीक है, so let us assume that suppose number of B negative ions constituting hmm, constituting the lattice is equal to 100. So ये हमने assume कर लिया, right? Suppose a binary compound है ना, so we assume that कि suppose a number of B negative ion constituting the lattice is equal to 100. Now number of tetrahedral voids are what? Number of tetrahedral voids. So number of tetrahedral voids are always twice the number of the B negative ion. So number of the tetrahedral voids. So number of tetrahedral tetrahedral sites. So number of tetrahedral sites is equal to 200. Right. Now, as 25% of tetrahedral voids are occupied by the A plus ion, so therefore the number is equal to 5. Right. Therefore, number is equal to 50 because 25% of this, na. So 25% of this is equal to 200 का 25% हो गया आपका 50. Right. So ये हो गया आपका 50. So what is the ratio? So ratio, इसका ratio of A plus and B negative. So A plus यहाँ पे 50, B negative यहाँ पे 100. So this ratio comes out to be 1 by 2. So what is the ratio beta? 1 by 2. So formula become A, B and 2. Right. So this is the formula A, B, 2. Chalo, let's move to the next question. This question is also from the solid state. That is what type of crystal defect is indicated in the diagram. So we all know that whenever the equal number of cation and anion are missing from the crystal lattice, this type of defect is known as Schottky defect, right? So this is a statement-based question and very simple one. Now move to the question number 86. So what the question number 86 asking basically? So in a cubic pack structure of the mixed oxidized, the lattice is made up of the oxide ion. 20% of tetrahedral voids are occupied by the divalent X plus 2 ions, and 50% of the octahedral voids are occupied by the trivalent Y plus 3 ions. What is the formula of the oxide? So you have to calculate the formula of the oxide. So suppose the number of oxide ion in the packing. So let us suppose number of oxide ions, right? Suppose the number of oxide ions in the packing packing. ठीक है. So suppose the number of oxides ion in packing is equal to n, and number of octahedral void number of octahedral voids is equal to n, right? So tetrahedral voids is always twice of the octahedral voids. So the tetrahedral voids is equal to 2n. Now, according to the question, X divalent ion X2 plus ions present, that is 220 upon 100 into 12. So on solving you will get 2 by 5. Hmm? So on solving you will get 2 by 5 n. Similarly, Y plus 3 ions present कितना दे रखा है 50%. So 50 upon 100 into n. So it comes out to be 1 by 2n. Right, 1 by 2n. So what is the ratio, beta? The ratio of x2 plus 2y plus 3. Right, to the ratio of O twice negative. Right, so what is the ratio? So it comes out to be 2 and 5 ratio n by 2 ratio n. So on solving you will get what you will get, beta? That is 2 to the 4, that is 4 ratio 5 ratio 10. So this is the correct one, that is 4 ratio 5 ratio 10. So what is the formula? That is x4 y5 O10, right? So the correct formula is option number B, right? So this is the correct one. So this is how you can calculate this value. Now move to the question number 87, right? So what the question number 87 basically asks, in the face center cubic crystal lattice, the edge length is 400 picometer and the diameter of the greatest sphere which can be fitted into the interstitial void without distortion of lattice is. So you have to calculate this. So we know that for the FCC, let me solve this question here. Okay. So we know this thing, if for FCC, for FCC, radius is given. Radius is equal to A upon 2 under root 2, right? 2 upon 2 under root 2. The value of A is also given, that is 400 upon 2 under root 2, and this is picometer, right? 400 upon 2 under root 2 picometer. As octahedral void is bigger in size than the tetrahedral void, the greater sphere will fit into the octahedral void. Obviously, the size of the octahedral voids are much more as compared to the octahedral voids. So the radius of octahedral voids is, so the octahedral radius of octahedral voids is equal to under root 2 minus 1 and multiply by r, right? So just put the value here. So this is under root 2. This is under root 2. This is minus 1 and value is 400 upon 2 under root 2. So just solve this value, what you will get. So for the diameter, this is the radius, and for the diameter, what you will do, you have to multiply by this 2. So this comes out to be 2 minus 1 into 400 upon 2 under root 2. Just so on solving, what you'll get around 117 picometer, right? So which one is the correct option? That is yeah, this is option number A is the absolutely correct answer for this question. Okay, chalo. Now move to the next question, that is the critical temperature of some of the gases are given below. SO2 430 Kelvin, Cl2 417 Kelvin, NH3 406 Kelvin, hydrogen sulfide 373 Kelvin. Which of these gases is most easily absorbed? Right. So we know that for the SO2 the temperature is highest, right? So highest the temperature and the gases is most easily absorbed. So the option is SO2 because the temperature for the critical temperature is high for the SO2. The higher the critical temperature, most easily gas is absorbed. Now, move to the question number 89. So at the 1000 Kelvin, the concentration of the substance of the following equilibrium, that 2SO2 plus O2 is given, and the values is also given. A catalyst is added that increase the rate of the forward reaction by the factor 1.88. Now the concentration of SO3 after the addition of catalyst attained equilibrium is. So you have to calculate. A catalyst does not change. We know that this thing. A catalyst does not change the concentration of reactant and product at equilibrium. So their concentration remains same, right? So the concentration remains same like 0.78 molar, right? Because the catalyst does not change the concentration of the reactant and product at the equilibrium. Now, let's move to the next question. This question is from the surface chemistry, right? That is question number 90. So they are asking the quantity of electrolyte required to coagulate negatively charged salt minimum in the case, right? The quantity of electrolyte, minimum electrolyte required होगा coagulate करने के लिए. So we know that for the negatively charged, right? So in case of Al having plus 3 plus charge, right? Where Ba having plus 2, they having plus 1 and plus 1. So which having the highest positive charge, that is aluminum. That's why the option B is absolutely correct. Higher the positive charge, easily coagulate the negative and vice versa. Now, move to the question number 91. That is the stability of the lyophilic colloid is due to. That is the absorption of the covalent molecule on the colloid. No. Size. No. Charge on the particle. Because of this charge only they are repel each other. And due to the repulsion, the stability of the lyophilic colloid is present. Right. So the charge of the particle. Now move to the question number 92. So this question is also very important. Question number 92. So and this question is very no, and it's a good question. So a crystalline solid X react with a dilute HCl to liberate a gas Y. Y decolorize acidified carbenophore when the gas Z is slowly passed into an aqueous solution of Y. Colloid sulfur is obtained. So X and Z could be respectively. So you have to identify X and Z. So a crystalline solid X react with the HCl, right? So how will you get to know out of these which is option is correct, right? So let me take the example of Na2S, Na2SO3, Na2SO4, Na2SO4, right? So basically Na2SO3, which is X, react with HCl to liberate SO2 gas. Always remember this. So they are saying liberate the gas. So which option is correct better? Because we know that whenever Na2SO3, they react with HCl, they react with HCl to form 2NaCl plus H2O and SO2 gas is removed. So this is X and this gas is removed, right? This is known as Y. So we can easily identify this X and Y, right? Now, this X, Y that is SO2, this SO2 react with H2O to form H2SO3. H2SO3, right? H2SO3. So which is the correct option beta for this question? That is option number C. That is Na2SO3 and H2S. Chalo. Move to the next question. That is question number 93, right? That is question number 93. That is which of the following is the highest coagulating power for the AS2S3 salt? We know that AS2S23 is a negative salt. So this is a negative salt. So for negative salt, we want positive. So again, aluminium, and here we have P also, right? So P and aluminium. So maximum charge is shown by the aluminium plus 3. So due to this plus positive charge, they are high. They are very good in coagulating. Now, move to the next question, that is 94. Which of the following, right? That is, which of the following is not a correct regarding the physical absorption of the gas on the surface of the solid, right? So, which of the following is not correct? So, basically, on increasing temperature, absorption increase continuously. This is not the correct, because in the physical absorption, on increasing temperature, absorption decreases. In chemicals, in chemical absorption, in the starting phase, if you increase the temperature, absorption increases, but after some time they start decreasing. So we can say that this statement is absolutely incorrect. That is, the following is not correct. So on increasing the temperature, absorption increase continuously. So this statement is absolutely wrong. Okay. Now move to the next question. That is question number 95. So the electrolyte having the maximum flow coefficient value of AgI and Ag plus solution. So basically, if flow coefficient value is inversely proportional to the flow coefficient power, right? So for the folliculating positively charged of PO3, ions have the maximum value, right? So which having the highest value better? So we know that for this Na3PO4. and which having the minimum value, that is NaCl, right? So NaCl will have the maximum flotation value because chlorine have the minimum flotation power, right? Because sulfide we have -2, PO4 we have -4, this is -2. So only chloride they having -1. So due to this only they having the highest maximum flotation value. Chalo. Move to the next question. That is question number 96. That which of the following curve according to the Friend-Wedge adsorption thumb? So we know that in case of Friend-Wedge adsorption thumb, how will you draw the curve, right? So basically we draw the curve like in x-axis we are taking log p. In y-axis you are taking log x by m. And this is the intercept here. And from here we have a Hmm. So what is the slope here? So slope is equal to nothing but 1 upon n, right? So this graph we get. This is the intercept. We can say that log t. So that is this option. That is option number D is absolutely correct for this question. ठीक है? समझ आया सबको? चलो. Let's move to the next question. That is question number 97. So a 50 ml of one normality oxalic acid is shaken with 0.5 gram of wood charcoal. Now, the final concentration of the solution after adsorption of 0.5 normality. What is the amount of oxalic acid absorbed per gram of the carbon? So you have to calculate the amount of oxalic acid absorbed per gram of the carbon, right? So let me explain this. The amount of oxalic acid present initially. Let me solve this in the next page. So the amount of oxalic acid. So amount of oxalic acid present initially is equal to N multiply by equivalent weight into volume. So what is the N for this question? So we can write as that is 1 into 63 into 50, and this is divided by 1000. So this is also divided by 1000. So solving, what you will get, beta? 3.15 gram. So this is the amount of oxalic acid present initially. So the amount of oxalic acid after absorption. So after absorption. So after adsorption, कितना amount बचा? That is 0.5 into 63 into 50 divided by 1000, right? So it comes out to be 1.575 gram. So this is equal to 1.575 gram. Now, how many amount absorbed? So amount adsorbed. So the amount adsorbed is 3.15 minus 1.575, and this is equal to 1.575 gram, right? So this is equal to 1.575 gram. So in this question, they're asking the amount of the per gram of carbon. So for the per gram of carbon, how much amount is absorbed, beta? That is 1.575 divided by 0.5. So it comes out to be again 3.15 gram. So this is the correct answer, that is 3.15 gram, right? Because they're asking per gram of carbon. So option A is correct. Now, question number 98. This is a similar to the standard isotherm curve. So it's a very simple question, right? We already see this question. So for this, we know that the slope is 1 by n and the intercept is log k. So this is the correct. The next question is, which of the following electrolyte we have the maximum flocation value? So we already discussed this thing. That is the flocation value. That is a flocculation. Flocculation value is inversely proportional to coagulating power. So they are inversely proportional to the coagulating power, right? So which option is correct? This having the minimum one, negative one. So yes, option number A is correct because all of them having more negative charge. Just chlorine having the minimum charge, so that's why they having the highest propagation value. Now move to the next question. That is question number 100. So on which of the following properties does the coagulating power of ion depend? So it will depend upon both magnitude and the sign of the charge. So this is also a very simple question. So I hope यहाँ तक सबको सभी समझ आ गया होगा. तो सबसे पहले मैंने लास्ट के कुछ जो क्वेश्चन थे 30 क्वेश्चन उसको डिस्कस किया. अभी स्टार्टिंग के कुछ क्वेश्चन रह गए हैं, आसान है बहुत, वो इजी है. तो वी आर गोइंग टू डिस्कस दोस क्वेश्चन एज वेल, राइट. सो आई होप यहाँ तक सबको क्लियर हो गया होगा. चलो. सो right. So let's see the question number 51. So basically benzene and toluene form an ideal solution and the vapor pressure of the pure benzene is 100 torr while that of the pure toluene is 50 torr, right? If mole fraction of benzene in liquid phase is 1 by 3, then you have to calculate the mole fraction of benzene in the vapor phase. So this is a very, very simple question from the chapter solution, right? So let me solve this question. We know that the total pressure of the solution can be calculated by using the formula PA into the mole fraction of this plus P naught P into XP. So this is how we can actually calculate. So this value is already given. This is equal to 100 torr. This PV naught is also given 50 torr and the mole fraction is also already given. That is if this is equal to 1 by 3, then obviously this is equal to 2 by 3. So just put the value. This is a very, very simple question. So on putting the value, you will get 1 by 2. So this is the correct one. That is option number B. Now move to the next question. That is question number 52, right? That is question number 52. So in the question number 52, what they are asking basically in question number 52. So they are asking which of the following solution will have the maximum lowering of the vapor pressure, right? Maximum lowering of the vapor pressure. कौन करेगा सबसे ज्यादा? So we know that for those who having the highest Ventov factor, that is for the BaCl2, we have a Ba plus 2Cl. So we have I is equal to 3. In case of NaCl, we have I is equal to 2. In case of sucrose, we have I is equal to 1. So which of the option is correct? That is option number B. This is the correct one. So this is a very simple question from the Ventov factor. Now, this question is also a theoretical question. That is the azotropes are. So what are the azotropes? So I already discussed here about easy questions. So इसीलिए हमने इसको last में discuss किया है. So what are the azotropes basically? So azotropes are the liquid which boils at the constant temperature without changing their composition, right? So which boils at the constant temperature and just behave like a pure liquid. So the option A, that is liquid mixture with distilled unchanged in composition, is called azotropes, right? Now, move to the next question. That is benzene and toluene form the ideal solution at the room temperature. For this process, which one of the following is the false statement, right? So, for the ideal solution, we know that delta G of mixing is equal to 0. This is the correct. This is also correct. This is also correct. So, only one thing, that is delta S of mixing of entropy. So, this won't be 0. So, this is the correct, incorrect, right? So, for this question, they're asking false statement. So, the option A is the false statement. Now, move to the next question. That is question number 55. So, what the question number 55 basically asks? So, in this question, they are asking uh, elevation in the boiling point of an aqueous solution of 0.52 Kelvin is already given 0.52 degrees Celsius. Kb is also given. You have to calculate the mole fraction. So we know by using the formula of elevation in boiling point, that is delta Tb is equal to Kb into m. So you can easily calculate m because delta Tb is given 0.52. Kb is also given 0.52. So molality comes out to be 1. Now, if the molality is equal to 1, what do you mean by the molality 1? Because as the molality is 1, it means as the molality is 1 signifies that 1 mole of urea is present in 1 kilogram of the water. This is the definition of molality, right? That is the the 1 mole of urea is present in a 1 kilogram of water basically, right? So, number of moles of water in the solution. So, the number of moles of water. So, we know that number of moles of water in the solution is equal to 1000 by 80, which is equal to 55.5. This is very common calculation. We already did this thing many times, right? So, this is equal to 55.5. Okay. Now, mole fraction of urea in water you need to calculate. So, the mole fraction of urea in water, that is mole fraction of urea in water is equal to mole fraction of urea, that is number of mole of solute, number of moles of solute or solvent divided by the total number of moles. Total number of moles. So this is how we can actually calculate the mole fraction of the solute or solvent in the solution, right? So this comes out to be 1 divided by 1 plus 55.5. So in solving, you'll get around 0.018. So option D is absolutely correct for this question, right? Now, move to the next question, that is question number 56. So what the question number 56 asks? Which one of the following statement is incorrect, right? So, greater the lowering of vapor pressure, greater is the boiling point. No, greater the lowering of the vapor pressure, greater is the freezing point. So yeah, this is the very correct one. That is the greater the lowering of the vapor pressure, greater is the freezing point of the solution. Now, move to the question number 57. So this question is also very, very important, right? So according to this question, a complex of iron and cyanide ion is 100% ionized at 1 molar. If the elevation in boiling point is given, then which complex is this? So we know that delta Tp is equal to I into Kb into M. So I is equal to delta Tb upon Kb into molality. So delta TB is given 2.08. KB is given 0.52. Molality is given 1. So on solving, you'll get I is equal to 4. So if I is equal to 4, so for which complex I is equal to 4? For the first one only, because here 3K and one negative ion is produced. So total I is equal to 4. Right? So option A is correct. So if you're taking option B, then we do not get all ions. In option C, we have 4 moles of K and 1 mole. So we have I is equal to 5. This is not correct. So which one is the correct beta? That is option number A. In this only we get I is equal to 4. So I hope यहाँ तक बिल्कुल clear हो गया होगा. चलो. So study the following figure and choose the correct option. So this question is from the osmosis basically. So what the question asks basically, there will be no movement of the any solution or the solvent of the BaCl will flow toward the NaCl. So obviously, because this is the more dilute solution. So from the dilute solution, that is the solvent movement from the higher concentration of the solvent to the lower concentration. So this statement B is absolutely correct. So this question is from the osmosis. Now, move to the next question. That is question number 59. That is the standard reduction potential, right? That is the standard reduction potential at 298 Kelvin for the following half reaction are given against each. Like Zn value have given, chromium having value is given, HNFA having value is given. Which of the following is the strongest oxidizing agent? So we know from the electrochemical series, if you move upward and get the negative value, if you down, they will get the positive value. More the positive value, more the oxidizing nature, right? So out of these following, which of the following have a higher positive value? That is Fe plus 3 only, right? So which of the following have most? That is option D, Fe. They having the higher positive electron reduction potential value. And that's why, wait, and that's why they are highly oxidizing in nature. Okay, now move to the next question. This question is from the salt bridge and it's a very easy question. That is the saturated solution of KNO3 is used to make the salt bridge. Why? Why they are used to make the salt bridge basically? Because we know that there is one condition for the salt bridge. There the velocity of both the ion must be same, right? Because the velocity of potassium and nitrate ion are nearly same. That's why they are used as the salt bridge. Okay, so move to the next question, that is 61. That is the standard reduction potential of copper plus 2 to the copper and the copper plus 2 to the copper are given. You have to calculate the standard electrode potential of copper plus 2 to copper. So this question we already discussed in the previous class, right? Right. So let's solve this question as well. So according to the question, this is already given. That is copper plus 2. When they accept 2 electron, they become copper. Right. So this EMF is given, that is called E1. Similarly, when the copper plus 2 accept 1 electron, they convert it into copper plus and their value is already given, that is called E2. So the net equation like copper plus gain electron to become copper. So how will you calculate this? So this is nothing but E3. So we can calculate E3 by N1, E1. We already know this formula and use this formula as well in electrochemistry. that is N2, and this is E2 divided by N3. So just put the value, you'll get the value that is 0.5214. So which option is correct, beta? That is option number C. Right. Now, the next question is, that is question number 62. They're asking, what is the electrolysis product of the NaCl at anode? So, electrolysis product of aqueous, right? That is aqueous NaCl at anode and cathode, they are asking. So, basically for the aqueous, we know that H2 and Cl2 are the aqueous NaCl product of anode and cathode, basically. Okay, move to the next question, that is, when the electricity is passed through a solution of AlCl3, 13.5 gram of air discharge, the amount of charge passed through is. So we know that Al having plus 3 charge, right? So this 3F having molecular weight is equal to 27 gram. This is drawn from the mole concept, right? So 27 gram produce 3F. So 13.5 gram produce how much? That is 3F by 2. So this is, we know that this is comes out to be 1.5F. So which option is correct, beta? That is option number A. So this is how we'll solve this question. Okay, move to the next question. That is question number 64. So what's the question number 64? Right. So this is how you can calculate. Next, the question number 64 is, an increase in the equivalent conductance of the strong electrolyte with a dilution is mainly due to. So why equivalent conductance of a strong electrolyte with a dilution increases? So this is a very simple question from the electrolytic conduction of electrochemistry chapter, right? So basically the increase in the ionic mobility of that. As we dilute, the ionic mobility increase, and due to this only, this behavior is takes place, right? So option A is absolutely correct. Okay, so next question is, calculate the conductivity of the CH3COH if the molar conductivity of this is given. So we know that our aim is to calculate CH3COH and CH3COONA, right? Plus HCl and subtract NaCl. So if you do this, CH3CONA value 91.6, HCl having value 425, and NaCl having value 128.1, right? So just solve this, you'll get the value, right? That is 91.6 and this. So on solving, you'll get the value is 388 something. So this is the correct one. Okay, the next question is, the which 0.1 molar aqueous solution exhibit highest electrical conductivity, basically. So we have this CH3COH only, we have in this ionic compound KCl. So this will obviously conduct the highest electrical conductivity. So this is how you can actually solve this question. So I hope this is clear to you, or we already discussed all this question related to this. So this is how you can actually solve this question. Now, next question is question number 67. That is, the instantaneous rate of disappearance of MnO4 in the following reaction is given 4.56 into this. And the reaction is this, and the rate of appearance of I2. So we know from the rate of reaction, that is the rate of disappearance of MnO4. So we can write as the reaction is rate of disappearance is equal to minus, and this is 1 by 2, and the value is given, that is 4.56 into 10 ki power minus 3. Similarly, you have to calculate the rate of formation, rate of formation of I2. So for the I2, we can write as this is 1 by 5, 1 by 5, and this is equal to concentration of upon dt, right? So this we need to calculate. So according to the rate law, rate of reaction must be equal. So we can equate this, that is minus 1 by 2 into 4.56 into 10 ki power minus 3, and this must be equal to 1 by 5 into the concentration, that is I2 upon dt. So this value you need to calculate. So on solving, what you'll get, better, you'll get the value, that is d is equal to 1.14. So this is how you can actually solve this question. So basically in this class, we will discuss solve all such questions related to this chapter. So let me solve the last question as well. That is, which of the following observation is incorrect about the order of the reaction? The order of reaction is always a whole number. This one is the incorrect one, right? Because order of reaction may be fraction, may be negative also. Okay, so next or last question is, for the first order reaction, the plot of T against log C gives a straight line with the slope is equal to. So you need to calculate the slope. So we know that whenever you'll get the slope, we have a value like minus 2.30. राइट। सो आई होप सबको समझ आया होगा, हम लोगों ने बहुत सारे क्वेश्चन सॉल्व किए इसमें, राइट। एंड वी आर स्टार्टिंग फ्रॉम द बैक साइड विच इन विच यू आर फेसिंग सम प्रॉब्लम बिकॉज द सॉलिड स्टेट पार्ट एंड द surface chemistry part they contain, solid state part contains some numericals, so we try to solve those numerical first, उसके बाद से हम लोगों ने ये भी डिस्कस किया, ठीक है। तो मिलते हैं नेक्स्ट क्लास में, वहां पे हम लोग बाकी का जो भी होगा उसकी क्लास को कंटिन्यू करेंगे और बाकी चीजें भी डिस्कस करेंगे। टिल टेक केयर और इसको ध्यान से देखो एक बार।